Okay, so current is dq dt. Capacitance is the amount of charge you have per unit of voltage. You can figure out the capacitance of this capacitor. You've got 1 microcoulomb of charge for 1.1 volt, okay? And you divide that out and you get about 1 micro unit of capacitance. The unit of capacitance is a coulomb per volt, okay? Okay, well, okay, for this circuit, the voltage, get the right letters there, is charge divided by capacitance. And the current is the voltage divided by the resistance. Something that we established, a few weeks ago. Okay, current's voltage divided by resistance. So dq dt is voltage divided by resistance, but voltage is Q over C. It follows that dq dt equals Q over RC, and that's a really simple differential equation, right? Okay, separate it. dq over q gives you natural log of q, right? dt over rc, integrate that, you get t over rc, right? Okay? So, and actually now, that's not quite going to work out, so let me explain quickly. The current goes in the direction of decreasing voltage, right? So you're going to have a negative here, and a negative here. And then you end up with Q equals some constant, which I'm going to call Q naught e to the negative t over RC. So you just have an exponentially decreasing current. An exponentially decreasing function has a constant half-life. Okay, your time constant is going to be RC. And that's the time required to fall to 1 over E. I think that's approximately 0.37. Of the initial charge. Initial charge is a charge at whatever time you want to say. Okay, one time constant, 1 RC later, you're going to be down to 37%. Okay? And the half-life is the time it takes us to fall a half. And you know how to calculate that. If you don't, review your pre-calculus or whatever. And we're going to be doing it in differential equations too. Nelson, you've already seen it. Okay?